Ladies and gentlemen, welcome to Coach Hanik's vector unit review. I think there's only 4 questions here. And the first one says, which vector best represents the resultant of the concurrent forces A and B in the diagram that follows? First thing I'm going to just label A and B. Doesn't matter which one it is. I'm going to redraw the diagram for you. Looks something like this. It's not perfect. Well, first thing, it's not in tip to tail format. Okay, so we must put that in there. Doing so, I'm going to pick one to move, and I choose to move this one, and I'm going to draw the resultant from start to finish. And the closest answer looks like answer number C, or letter C. For the next one, I don't know why it's just saying 1. We're just going to put a 2 there. They all say 1. The resultant, that's key, of 2 concurrent forces is a minimum when the angle between them is. Well, concurrent means acting at the same time. So here's an example. Here are 2 vectors, we'll call this A and B, acting on the object, whatever this point is here, at the same time. We know it's not in tip-tail format, so I must move one of these. And that gives me my resultant of that one. But here I want to create the minimum. So let's see what happens. First, if I have 2 vectors, A and B again, and they're going in the same direction, we have vector addition. And that would give me my max vector. If I have one going to the right and then also one going to the left, as you can see, they will cancel each other out, which is called vector subtraction. And this would give you the minimum vector. Okay, something just happened there. I don't know what, but I can't write straight. So it's the minimum vector. So we have here is at 0 degrees. They're going in the same direction, and that's same direction. Where 180 degrees, which is the bottom one, is opposite, equals opposite direction. So the answer is going to be, to give you the minimum, it's going to be 180. This is number 3. Again, I don't know why it has 1 here. Which pair of concurrent forces may produce a resultant of 20 newtons? So let's check this out. Let's just look at choice A first. If I have a 5 and a 10, I get 15 newtons, and that's at 0 degrees. If I have a 5 and a 10, it gives me a 5 newtons at 180 degrees. Anywhere between 15 and 5, I can make a resultant if I change the angle. So if I go from 0 degrees down to 180 degrees, I can get a 15, 14, 13, 12, 11, all the way down to 5. So looking at this, I want to create a 21. The answer is going to be B, because 20 and 20 gives me a max of 40, and that's at 0 degrees, or 40 newtons. And 20 and 20 going opposite directions gives me a minimum of 0 newtons. And that's at 180 degrees, and I know that 20 is in between 0 and 40. Okay, last one, number 4. Into how many possible components can a single force be resolved? The reality is it unlimited or an infinite? Here we go. The simplest way to break it down is we have 2. If this was my resultant, I could break it down to 2, but the reality is, if I go back to that, it could start this way, go this way, this way. As long as they're in tip-to-tail format, I could do this for infinity. You did this with the walking lab. They're just all straight lines. No vectors or curves, so this is on the right-hand side here. This is really bad. And come back eventually, and that would create the resultant. So I could do an infinite or an unlimited number.